Hello everyone, I am Reha. Today I will present you my term project of ME 536 course. My project is feline detector. Let me firstly present you the aim of the project. The aim of the project is simply design a feline detector. In my scenario, we have four kinds of felines such as lion, tiger, cheetah, and leopard. And my code tried to estimate the new image input is one of these four kinds of feline or not. If not, it also tries to estimate the new image is a feline, which is not these four kinds of felines or completely a different thing. And also, if the new input is one of the four kinds of feline, also detect the which one. And in this project, I use PCA analysis, ANN, CNN, and image processing. I mean specific filters and kernels. In my data set, I have 700 training images for each clusters and 300 test images for each clusters. All images are 64 by 64, and the single test image is inside the test image folder. So let's start. Firstly, I import the required libraries you can see here, then start the pre-processing. Firstly, import my data with image data generator, and also I divide the pixel values by 255 to compress pixel values between 0 and 1. And then I start my first CNN. I use TensorFlow Keras library here. And here I start my CNN and add convolution layer with 16 filters, and my kernel size is 3 by 3, and activation function is rectifier function. And my input shape is 64 by 64, as I said here. And of course, my images are RGB. Then I add an pooling layer with pool size 2 by 2. And then I add one more convolution and one more pooling layer to my CNN. Then I import my data training set into this CNN and take my data. And let's look at the data shape. I have 2,800 images, okay, and its width and height is 14 by 14. It's weird. Well, actually, it's not weird because I use convolution and pooling here. It's at the beginning, it is 64 by 64, but it reduces the 14 by 14, and it is my channel size. So let's define my first kernel filter. My first filter is, I also use TensorFlow here. You can see here, it is an edge detector. Let me show you here. From the lecture notes, I use this edge detector as my first kernel, and I reshape it. Then I use again TensorFlow to apply this kernel on my data set. And let's check the shape again. It is 12 by 12. It is 14 by 14. Before this applying these kernels, okay, it's 3 by 3 kernels, so it reduces 14 to 12. It means 2. It's okay. And this is my second kernel. Actually, it is an arbitrary kernel. I hope to detect the patterns on leopard from this kernel. Actually, maybe it's not. I don't know. I will try. Actually, I tried. And reshape my kernel again here and apply it on my data again. And let's check the dimensions 8 by 8. It was 12, reduces to 8 because it is 5 by 5 kernel. Okay. Then I have to flatten my data with again from TensorFlow, I use a model to flatten my data. We flatten our data for PCA analysis actually. So I have 2008 data points and 8 by 8 by 32. It means 2048 dimensions. Let's check it. Okay, no problem. And remember, we have to transpose this data for PCA analysis because we use data points on columns and dimensions on rows. Remember. At PCA analysis, I use zero mean. I use my zero mean function here and apply it on my data. Transpose here, you can see here, and start for SVD analysis. I use NumPy linalg SVD function here and check sigma values for real rank. When we look at the graph, it's hard to say something, but it's look like 1 or 2 is the real rank. And let's check. We see the first sigma values is important. Then check the first 15 or 16 sigma values, and you can see here it's look like again first and second, maybe the third can be the real rank. Then let's check the calculated rank, and it's 1204. It's too high. So let's use another method, energy method here. And when we use the energy method, we see that the real rank is 126. It's not look like in the graph actually, but I will use this rank. I don't know why. I rely on this method. So I set my rank as 126 and revealed my matrix, data matrix, and transpose it again because I transpose while I use zero mean. So transpose it again, and let's check the shape. Okay, 2,800 data points with 2048 dimensions. Then the next part is ANN. I use again Keras library here. Starting my ANN, I use 4 layers, actually 5, but these 4 hidden layers here. Rectifier function is again the activation function. I try to this here like a triangular shape. So these units are because the half of them. And add my last layer with 4 outputs because I have 4 outputs, 4 kinds of felines, and use activation function as softmax in order to my result should be between 0 and 1. My results actually, and then I multiply them with 100 to take my percentage value. So because of that, I use softmax here. Then I compile my ANN with categorical cross entropy here, and metric is accuracy. And also I have Y values for my ANN. I mean the result values, but I don't have. So I have to create a new matrix, new array actually here with 2,800 dimensions. But Keras ANN only accepts one hot encoded output. So I apply one hot encoding here on my Y set, then train my ANN with this data and Y set. Batch size is 32 and I use 100 epochs. And let's check, I have 27.68 accuracy here. It's kind of low. It's so sad. But let's try our code. I use the same steps for pre-processing of my test image, single test image here. You can see here, every step is the same except the specified kernels. Oh, sorry, specified kernels right here. Only PCA analysis, zero mean here. SVD, only SVD is not here. Okay, let's check the image shape. Okay, one image and 2048 dimensions. Let's check the results with ANN Predict. Firstly, look at the summary here. We can see my summary and check similarities here. Oh, I'm sorry. And I my test image is here. It's a cat here. You can see here, and it's 23% tiger, 21% lion, and 18% leopard, and 36% cheetah. And my result printer here, it says it's new kind of feline. It's correct. But actually, it's correct for this image. Maybe the image can't work because my accuracy is too low. You can see here. So sad. But that's my project. Thank you for listening. Have a good day.